Hello, everybody. Welcome back to our Raising a Mathematician extra math classes. We will be continuing our discussion on the theory of precalculus, which we briefly, were introduced to last time. We understood the concept of a slope of a graph. We studied trigonometric functions, and we also visualized what is the meaning of slope being 1, slope being 2, slope being infinity. And we realized that the slope is equal to the tan of the angle. We call the angle theta, that's the convention, and that is the angle of inclination of that particular line. So if this was our line, we take it with regard to the ground, this is our angle, the slope would be the tan of that particular angle. For those of you who are not completely remembering that, the tan of an angle is the sine of that angle divided by the cos of that angle. The sine is the opposite side over the hypotenuse, and the cos is the adjacent side over the hypotenuse. So we have our opposite side, we have our adjacent side, and we have our hypotenuse, and we would do opposite over adjacent to get tan. So in this case, the slope of this line is O divided by A. Okay, so that's pretty much straightforward. And we were discussing this, and then we had a very interesting discussion where we said, what is the steepest slide possible in the whole world? We said that is a slide which would be a straight line almost. So because the tan of 90 degrees is close to infinity. As the angle approaches 90 degrees, the tan of that angle becomes close to infinity. And we can write this using something that we learned last time. We can write this using limits. Limit as x tends to 90 degrees, tan of x equals infinity. Any questions as to the notation being used here? Because this is what we studied, I think, 3 classes ago when we studied limits. Now, as x approaches 90 degrees, the tan of x approaches infinity. That's why we say limit x tends to 90 degrees, tan of x equals infinity. We can even write it as approaches infinity just to avoid any confusion, because we don't want to say anything is equal to infinity, it approaches infinity, right? Now, one thing that I want to clarify before we move forward is the notion of radians and degrees. I don't know how many of us are familiar with that. The convention in mathematics is usually to use radians to represent an angle rather than degrees. We don't usually say 90 degrees, we say pi over 2, right? Is anybody having confusion with that? So pi degrees is 180 degrees. So straight line is pi degrees. So 90 degrees becomes pi over 2, 45 degrees becomes pi over 4, and 2 pi becomes 360 degrees, which is the complete angle. So that's the notation usually used. But if you write 90 degrees, people are usually smart enough to understand that you're talking about pi over 2. They will not think you're talking about 90 radians. Because if you think about radians, then pi is 3.14 approximately. So when you say pi degrees, you're saying 3.14 degrees, So people will not think you're talking about 90 radians. So that's why the degree is important. Okay, so that's sorted. But that still doesn't explain one question. Now I have this line, I can solve its slope, right? We know how to do. I have this line, this is a steeper slope, I can still solve it. I have this line, which is very, very steep, but I can still solve its slope. I have this line with slope 0, it's just lying on the ground. But although these graphs are very nice and these lines are very nice, in reality, we don't encounter such situations, because if you were to look at a graph, it will usually look something like this. It won't be just one straight line unless you're doing some simple plotting, x is equal to y sort of thing. How do you calculate the slope of this particular graph? Or simple question, how would we calculate the slope at a particular point? Tangent. That's very nice. That's a very good suggestion. When we calculate the slope at a given point, we are actually calculating the slope of a line which will be drawn in such a way that it only touches that point once and touches the graph once. There's only one such line that can exist. There's any other line, it will touch some other portion of the graph. So it has to touch it only once as a tangent. We calculate the slope at that particular line. Okay. Now I wish to introduce you to a formula which is a very important formula when we calculate slopes. And there's a different name for slopes. We can call it derivatives. We say derivatives, you're trying to calculate the derivative of a function. What does that actually mean? Has anybody heard this word before? This is one of the first things that we would have to study when we want to study calculus, when we are studying functions, when we're studying slopes. What is the definition of a derivative of a function? Does that sound familiar to anybody? Yes, it sounds familiar to Vansh. Vansh, do you want to unmute yourself and tell us all what you think it means? Any thoughts? Nope. You can type. Okay, we'll wait for your reply. It is differentiation. Yes, that's correct. It is the notion of differentiation, but we'll not go ahead of ourselves. We'll be very slow. We'll try to understand what this means. We want to know what we're trying to do, rather than just using words which are already well known and just trying to plug in formula. We want to know what we're trying to do. So basically the notion of a derivative, is there any answer? Okay, no. The notion of a derivative is trying to calculate what is the rate of change of the entire function, right? What is the meaning of slope? Still talking about the change in the inclination of the y coordinates. Basically, every function is graphed in the following way: f of x equals y. So the x-axis, you have the x coordinates, and then the function values are plotted on the y-axis, right? I mean, with regard to the y-axis. So a derivative of a function is just a measure of calculating the rate of change of the entire function over a given interval. Okay, and the way we would want to do it is by calculating the slope at every given point. Okay. Now we yes.
Okay.
I think okay. So it's the way to show the rate of change of slope. Very, very good answer. Let's define slope in a slightly different sense now. We defined it using tan, and we did it's a sine over cos, and we did all that, angle of inclination. There's a simpler way to think about slope. If you look at the slope, what were we dividing it by? We were dividing it by this over here, and then we were by this over here. What exactly is that? Okay, let's look at it this way. We have a graph, okay, and we have this line over here. We want to calculate the slope of this line. So we draw some imaginary dots over here, and then we say this is equal to, let's call this, actually I want to call it by its actual name, but I think it will be confusing. Let's call it P. Let's call this Q. Do we all agree that the slope of this line is going to be P divided by Q? Because we're doing the tan of that angle over there. So that is going to be opposite over adjacent. In this case, P is the opposite and Q is the adjacent. So it will be P over Q. Are we in agreement with this at this point of time? Is everybody okay with that? The slope of this line is P over Q.
Yes.
Okay, thank you. Now the question arises, what exactly is P, what exactly is Q? Because they are abstract notions. We don't want to generalize something by just, giving it some random name. In this case, P happens to be the change in the y-axis from here till here. We started off with a function value somewhere here. That's why we had this point. And then we moved all the way over here, right? So this is, let's say y equals 2 over here, y equals 4 over here. So basically the y-axis, we have observed some change from the start of our interval to the end of our interval. And another way of writing P is change in y. This is the length. It's the length between our starting y value and the ending y value. We start off at a y which is at this point over here, and then we changed over here. So the P is basically the change in y. Can somebody type in the chat what is Q? Using this similar language, can we think of a way to represent Q? Just like how we represent P as the change in y-axis, change in the y coordinates over the interval. Very good. It is the change in the x-axis. Perfect. Yeah, I'm getting a lot of answers. Very, very happy about that. Q is the change in x-axis. So another way to write slope, I don't know how many of you are familiar with some concepts in physics, or if you've seen this notion before, we usually denote change by this symbol delta. Whether it's the change in heat, change in velocity, change in time, change in distance, change in energy, change in momentum. We use this delta to represent change. I am no one to tell you why that notion of using delta came about for describing change. Maybe some significance in ancient Greece, which we don't know about. Maybe something to do with the pyramid. It looks like a pyramid. So maybe they want to say this is something which never changes over time. So maybe then you bring in the notion of only thing constant is change. This is just me extrapolating. Okay. So we could represent slope as a change in y divided by change in x. That's exactly what we did. We first realized that the slope is the sine over the cos, which would then mean it's the opposite over the adjacent. The opposite side happens to be the change in the y-axis because the length of the opposite side is the ending y value minus the starting y value. Then the adjacent side, q, is the starting, so the ending x value minus the starting x value. So it's the change in the x-axis. The slope is opposite over adjacent, p over q, which is the change in the y-axis over the change in the x-axis, which is delta y over delta x. That's the notion of slope. Okay?
Yeah.
Yeah. Now, coming back to our original question. Just a second. Okay. Coming back to our original question, how do we understand the notion of slope over an entire function? Right? We don't want to do it at just one point. We want to somehow generalize it to the entire thing. So we could come up with the following understanding. Okay. Suppose our x was to change, let's say from x to x plus delta x. Let's say that our x started off at something and then it changed to x plus delta x, where this delta x is our change. Remember, so we started off at x, then maybe we added something or maybe subtracted something, doesn't matter. Delta x can be positive, it can be negative. It says that x started off as x and then it changed to x plus delta x. And let's say y started off at y and then it went to y plus delta y. Okay, suppose this was the case. What would be our slope? This might be a little hard for some of you to visualize. This kind of way of writing equations might be new to you. But we want to make sense of this particular example. So basically, so for those of you who are new to proof writing, those of you who are new to this entire idea of writing equations like this, so far we were working with examples, right? I was drawing, I was telling you this is the length, this is the width, this will be the x over y or y over x. But if we want to take a general situation where x changes to x plus delta x, y changes to y plus delta y, and we want to see what will be the notion of a slope for this situation. And we will use the formula that we just derived. It's delta y over delta x. So the first thing we will do is the slope, no matter what the equation is, should be delta y over delta x. Now, in this case, what is our delta y? So y changed from y to y plus delta y. So do you agree with me that delta y would then be y plus delta y minus y. Do you agree with this? Because the function ends as y plus delta y. It starts as y. So the change should be y plus delta y minus y. I know this is trivial. You can literally say that it's delta y, but I want to write this explicitly. We started off at y. We ended at y plus delta y. So our net change would be the ending minus the starting, which would be y plus delta y minus y. What happens to the x value? It becomes x plus delta x minus x. So far, so good. We have not done anything new. We're just writing these new variables into our previously derived equation. Now here comes the trick. We want to write this equation in a beautiful way to make life very simple for anybody who looks at this. We want to make use of the fact that this is a function. These are not two random variables, y and x. They are connected to each other. Can anybody tell me how y is connected to x in this situation? I'm not randomly picking two situations and giving them names. There is some connection between the two variables. What is y? Very good. I got one answer in the chat, but I'll wait for some more. Is there a way by which you can write y as something to do with x? It's connected to x in some way. It's a function. That's my clue. Nobody else wants to give it a shot? Okay. Good. I got one more answer. Y is just f of x, right? It is the function value at the point x. In this case, we are defining a slope based on the change in y to change in x at that particular point. This is not some random change in the graph, delta y, and some random change. It's happening at the same point. X comma y is our point, which is being changed to x plus delta x comma y plus delta y. So they're all interlinked. Y is f of x. Let's write that f of x equals y. Is there anything else you can tell me with this situation? F of x equal to y. So what would be f of x plus delta x? Any guesses to that? Y plus delta y. Very good. Very good. Okay. So if y happens to be f of x, then and delta y will be delta f of delta x, then f of y plus delta y should also be f of x plus delta x because the function value is changing at that particular point. So we define f of x to be y, and then we changed x a little bit, and then we said that when you change x a little bit, the y will also change a little bit. So the change in x, we called it x plus delta x, and the change becomes delta x, and then y becomes y plus delta y, so change becomes delta y. So now we know that f of x plus delta x should be y plus delta y. Let me actually draw this for you. Let's make it simpler. Some of you might be confused. We have this, we started this point and then we went here. This is point x comma y. This is x, this is y, this is x comma y. Then the function changes over here. So here we have x plus delta x, and here we have y plus delta y, with this distance being delta x and this distance being delta y. We just changed y by something, we changed x by something. So we have this point x plus delta x comma y plus delta y. So f of x plus delta x would be y plus delta y. F of x would be y. That's how the graph is plotted, right? You plot the y coordinate based on the function value at the respective x coordinate. Okay. So our equation, which was looking a little messy, it was looking like this. It was y plus delta y minus y divided by x plus delta x. If we want to clean this up a little bit and keep it constrained to x, we can write this as f of x plus delta x, agreed, minus f of x divided by delta x. I will pause for some time and allow all of you to look at this for some time and allow it to sink in. Let me know if you have any questions. Y plus delta y minus y is f of x plus delta x minus f of x. And then the denominator is just cancelling out the two x's and leaving delta x over. Thoughts? Is it a little too generic? Is it looking like, how did you arrive at this from that? Do you feel like that? Does anybody have any speculation that this doesn't look right or something? Or have I missed something? All we did is change our slope equation, which was delta x or delta y over delta x. We just changed it to make it look like it's only going to involve x. So that, I'll tell you why we are doing this. Why don't we want to involve two variables? Because we want a magical equation which will allow us to calculate the slope of a function at a given point just with the function. We don't want to calculate the y as well and complicate things. We just need x, we are done. We can do f of x plus delta x. Because again, that ambiguity shows up. What is this y? Where is this y defined? We want to make it clear. This y is the exact parent of our x. It's the function value. It looks so much simpler now. We just have f of x plus delta x, f of x and delta x. So the only thing that we would need is that delta x. We just want to know what is the change. If that is given to us, we can solve this equation. Aha. Somebody messages in the chat, we can limit this expression to find the slope. Okay, now you all are smart people. We have this equation. Can somebody tell me when this equation will be utterly useless? In which situation will this equation not really give us the slope? Or not really help us? Somebody said when delta x is equal to 0. If delta x equals 0, then our numerator becomes f of x minus f of x, which becomes 0. Denominator becomes 0. We get 0 divided by 0, which is not defined. That leads into a tricky situation. But let's say that it is not 0. But in which situation do you think that this is not really very useful to find the slope at a given point or of a given function? This will give us some huge error. Will not really help us much. Yep, it's when delta x is really, really large. Because if your change is so large, I'll tell you what can go wrong. You have this function over here, okay? You start here and this does all sorts of things. It's a ridiculous function and it finally ends over here. Now, if we were to apply our slope equation or delta x and all of these things, we'll be looking at this point A, this point B, and we'll be subtracting that and using that to calculate our slope. That doesn't really help me much because there's so much information that's being lost when I go from B to A. See, the change from my x to x plus delta x is really big. That doesn't really help me that much because I want a very good approximation to the slope of that function. I don't want to take it at a random, start and end point, which is so big. I mean, think about it. If that A was to end exactly where this B was, you'd get the slope to be 0. I mean, yeah, maybe, but I want more information. So now can somebody tell me when will this equation be very, very, very powerful? When delta x becomes what? I got one answer, waiting for some more. What should happen in our equation? Let me write that equation again. F of x plus delta x minus f of x divided by delta x. Yes, very, very small. When delta x becomes smaller and smaller and smaller, but should not be 0. It should not be 0. That will cause chaos. 0 divided by 0 drives everybody crazy. It should become smaller and smaller. It should tend to 0. I like that. That's a very good way to write it. It tends to 0. That doesn't become 0. Limit of delta x should go to 0. Because then what will happen is on your graph, you'll have one point over here, x. Since your delta x is so small, your change will be very close to x. So you'll get the slope very accurately at that particular point. And you can keep doing this more and more and more and more and more and get all your accurate slopes throughout rather than picking a big interval and subtracting from one side to the other. We'll make things a little, I don't know, I will take an opinion of you guys. There are two ways of representing this function. Some people write it like this, f of x plus delta x minus f of x divided by delta x. Some people like to write it as f of x plus h minus f of x divided by h as h tends to 0. I prefer this because again, h is like a different variable, but some people like that because you're saying h goes to 0. So it's like a mutually exclusive thing that you put there as a placeholder and it goes to 0. But we can keep this. So here's your first big definition. The derivative of a function at a given point x is the following. It is f of x plus delta x minus f of x divided by delta x as delta x tends to 0. No matter what the function is. Let's look at an example. Let's pick a very simple function. So f of x equals, let's go with the 3x plus 5. This is our function. Just look at the power of this formula. You don't need to draw anything. We can just use our equation to solve this. Now we want to do limit as delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Right? So before I reveal the answer, I want to see how many of you remember our limit class, which we did, I think, 2 or 3 classes ago, where we had the situation where the denominator could go to 0, but there was a way by which you would solve it in such a way that until the very end, you don't need to do the substitution. Can I give you guys 5 minutes to try and solve this before I reveal it? Because I think you will be able to do it. I want all of you to give it a shot. Okay? So exactly, let's say, I'll give you 5 minutes. Right now it's 9:32. At 9:37, I will reveal the answer. Is that okay? Let me know if you have any questions. Good, that's correct, but we'll wait for everybody else. This is just algebra, but you'll have to be a little careful when you deal with these kind of situations. And it's very important that delta x tends to 0. It's not equal to 0. Good, I have 2 answers. That's nice. That's nice to see. Both of them are correct. Four more minutes. Take your time. Okay, let's wait for a minute more. Because most of you, I think, have gotten it. I just want to give everybody a fair chance of trying to solve this. Is anybody feeling totally lost here and not knowing what in the world is going on? Please let me know. It took me quite a while to make sense of any of this stuff. It took me a very, very long time. I was not able to understand what's the point of all these deltas flying around in my notebook. So do let me know if this doesn't make complete sense. Okay, so let's try to solve this. We'll do something very simple. When we have f of x plus delta x minus f of x divided by delta x. So what is f of x plus delta x? Because our f of x was 3x plus 5. So if we have to do f of x plus delta x, this would be 3 times x plus delta x plus 5. Does everybody agree with this? This is f of something, and in this case our something is x plus delta x, so it would be 3 times x plus delta x plus 5. Is that okay? Does anybody feel that's not okay? Okay, good. So if we were to write it over here, we would have 3x plus 3 delta x plus 5. I'm opening the bracket. Okay, so 3 times x plus delta x is going to be 3x plus 3 delta x minus 3x plus 5 divided by delta x. Is that okay? Hello, am I audible? Can you guys hear me? Okay, good. So right now, the 3x and the 3x get cancelled. 3x and the 3x get cancelled. 5 and the 5 get cancelled because it's subtracting, right? So what remains is 3 delta x over delta x, which is equal to 3. We don't even care what happens to delta x. This doesn't matter because the delta x gets cancelled. In this case, whether delta x went to 0, whether delta x went to 10,000, whether delta x went to negative 20,000, our answer would still be 3 because we eventually would have 3 delta x over delta x. So delta x gets cancelled. Okay? Any doubts about this? Okay, so we will end for today, but I want to give you a question to think about. You can think of this as a homework, but it's not. I mean, there's no need for you to do this because I think that the next time I'll see you will be 3 weeks from now, or maybe 4 weeks from now, depending on how the days pan out. Can you try to solve the derivative of the function f of x equals x squared? Use the exact same formula. Try to do f of x plus delta x minus f of x divided by delta x as delta x goes to 0. Try to do it for this particular question, and it should not be too hard. It's a little harder than the 3x plus 7, but 3x plus 5, but I don't think it'll be that bad. So yes, I'm going to stop recording now, but I'll stay back if you have any questions. Thank you so much.